Jason drives due west with a speed of 35 miles an hour for 30 minutes, then continues in the same direction with a speed of 60 miles an hour for 2 hours. Then he drives further west at 25 miles an hour for 10 minutes. What is Jason's average velocity? Sketch a motion diagram at 10-minute intervals. So this is, by the way, this is page 112, number 19. Turn this around. So he drove due west at 35 miles an hour for 30 minutes. Then he continued to drive west at 60 miles an hour for 2 hours, which is 120 minutes. And then he continued to drive west 25 miles an hour for 10 minutes. So what I did first was look for the amount of miles traveled total. So for this, I took 25 divided by 6, which gave me 4.1 miles. And then for this one, if he drove 2 hours at 60 miles per hour, obviously it's going to be 120 miles plus 17.5 miles. For this one, I took half of an hour, which is 30 minutes. So I took 35 miles divided by 2, gave me 17.5 for a total of 141.6 miles. So the definition of average velocity is delta R over delta T. So you're going to do R final minus R initial, and then your final time minus your initial time. So that gave me 141.6 miles minus 0. Started at 0. Then I added up all the hours, which gave me 2.66 hours minus 0. And then that gave me 53.23 miles per hour. And it's really important to state what direction you're going in, which is west. And then for the, I didn't feel like rewriting all this, but for the, what is this called? I can't ever think of the name. Motion diagram at 10-minute intervals. So along my y-axis, I have miles, and along my x, I have my time, which is at 10-minute intervals. So at 10 minutes, what I did was she traveled 30 minutes at 35 miles an hour, and we found out that she went 17.5 miles. So I took 17.5 and divided it by 3. And that would give me 10-minute intervals of 5.8. So I did that for the first 30 minutes. And then we found out she traveled 120 miles. So I divided that by 10. And I added that so on to the graph. And it's a pretty linear graph. So I was pretty happy with it. It's a pretty fun problem to work out. It definitely got me thinking. So this is my problem.